All right, everyone. If you haven't been to enough SBOM talks already, we're here to fill that gap for you. All right, so this talk here is specifically on enhancing SBOM generation, filling in the gaps on making SBOMs more actionable. My name is Ian Dunbar-Hall. I work for the Lockheed Martin SBO. Just a little bit about myself. I'm a governing board member within OpenSSF, where I do a lot of work specifically on BOM-CTL, a project that is intended to help move SBOMs from one location to another and help make them be format agnostic. Along with that, I don't do so much homebrewing, backpacking anymore, but as a father, I spend most of my time playing T-ball now. All right, I'm going to turn it over to Gary to introduce himself.
Yep, Gary O'Neill. I run a little consulting business, but most people know me as Mr. SPDX. I have been co-leading the SPDX tech team for quite some time, so quite familiar with SBOMs for like the last 12 or 15 years. Currently, I'm roaming the country in a small camper and doing a lot of hiking and maintaining a new application called Beer Hiker. So if you like beer and you like hiking, let me know.
I like the plug.
I know you're not supposed to talk about, your own software here, but it's not really proprietary. It doesn't really make any money, so I think it's okay.
All right, so what we're going to talk about today is really three areas. I'll say better SBOM generation. We're going to talk some about the SBOM producer lifecycle, and lastly, some lessons learned around applying this. Everything we're talking about today really came out of some work we did through the CISA community. There's a great SBOM community run specifically by Alan and Victoria over at CISA that if you don't participate in, and you're interested in kind of understanding what's happening at a macro level, they do a really good job and they meet on Mondays. Highly recommend people check it out. So within that community, we had a Tiger team, a platypus pod as it was called also, that was really focused on generating better SBOMs. And we put together some reference implementations, and through that we've kind of explored this life cycle that we think most people should be following. So when we say this, what is better SBOM generation? I'm going to show of hands. Who here generates an SBOM for one of their products or open source projects? Okay. Who here knows who the author is in the field for author in it? Who here declares their top level license? Okay, more people do that. Good. Those are the types of things we talk about when we say enhanced or better SBOM generation. Most people today really focus on just generating the SBOM and they ship it. Right? And I see this happening on a commercial level, right? As someone who's into SBOMs, I get a lot of SBOMs through my company, right? I see a lot of what vendors are providing. And I've personally seen SBOMs that are unbelievably terrible, right? Because they check the box, they are NTIA minimum compliant, but then you actually look at them and you'll see stuff like, I've seen the Acme Corporation license inside of commercial products, inside of what they declare in an SBOM. Right? These are things that people are not checking when they generate SBOMs. We want to see better SBOMs being generated. So what do we say when we say an SBOM? Producer lifecycle. Well, we see generation as really the first step of a multi-step process. Right? Through that, you generate an SBOM like you normally would, using Syft, Trivy, maybe it's the CycloneDX tools, maybe it's SPDX tools. Doesn't really matter. But you need to go through and update it, right? You need to augment the top level metadata. You need to probably enrich it so all the components that are there, add additional metadata about them, verify that it meets the format, verify that it meets maybe NTIA minimum elements, maybe some other standard. And then you probably want to assign it so that whoever receives it can verify the contents. If you're looking to learn more about document linking, I would say go to BOM-CTL. We'll be talking about it tomorrow at the OpenSSF booth. So today, what do people do, right? They generate an SBOM using your favorite tool. Again, I'm going to say format is a personal choice. What tool you choose is a personal choice. It doesn't really matter, right? But at the end of the day, really easy step. Solves about 90% of the problem for folks. But the reality is it's missing a lot of important information. First and foremost, like I said, the author. Most people do not declare themselves as an author of that SBOM. I think that's really unfortunate, right? How do I know that this is the authoritative SBOM by the producer of the software if I don't know who the author of the SBOM is? It certainly isn't Trivy. It certainly isn't Syft, right? Supplier. Supplier can be a little bit of an ambiguous term, but ultimately, is that GitHub, GitLab? Is it maybe a third party if it's commercial software? Those are important things to understand when we talk about distribution of software. Additional metadata, right? If you are scanning anything, right, you probably want to figure out what the source code for that project is. Where can I find it, right? Mapping open source projects to repositories is solved in some ecosystems, but there's not really a good universal way to figure this out. You, as the author of that SBOM, should declare these things. Copyright, license, repository location, right? And these basic things really help you define what is a better SBOM, right? So if we talk about how to do that, we call this the augmentation step, right? You can go update the top level information. Augmentation being separate than enrichment of the lower level components. You can do this automatically through your pipelines. The tools already exist. I'm going to talk about two different approaches to this. One of them is with SBOM ASM. I'd say a shout out to Interlinks. They have done a really good job creating some open source tools that are really succinct and small to help out with these steps that are format agnostic. I'm going to really highlight them here. I have no affiliation with them, but I think they do a really good job, and the tools are open source. So one way to do this would be through SBOM ASM. The other one is through, I would say, statically merging SBOM data into an existing SBOM. So I'm going to highlight a little bit of both of these. So here's literally a command that I copied out of our working examples that we have that people can use about how to edit this top-level metadata for, in this case, a CycloneDX SBOM, but could easily be through an SPDX one. You can specify what the scope of the change is, who the author is, supplier, lifecycle, repository license, all right, and pipe it out to a new file. Pretty easy step. You can include it in your pipeline. And this alone gets you well ahead of the majority of other folks there in terms of the quality of your SBOMs. Contentious term, I know, but quality of SBOMs is really important here. You do the same thing for the primary component too, right? Separating out the content for the document versus the content of your top-level component. And here's kind of an example of what the result of this approach is, right? Before we ran Trivy, it didn't have things like this lifecycle. It didn't have the URL, the URI in this case, for the supplier. It didn't say who the authors were. It didn't specify a license with an appropriate SPDX ID, right? This information is very basic, very simple to add. What I do for most of my projects, I actually use the static JSON approach. In this case, I tend to use CycloneDX as my preferred SBOM format. Again, personal choice. But it allows me to basically use JQ and smash two JSON documents together. This also allows me to have a lot more description here and be more expressive about specific fields that I want to modify versus only what the SBOM ASM tool allows. All right, so I've gone through, smashed all my SBOMs together. I now have one with much better top-level information, right? We've augmented it. Now I need to enrich it. So the reality is that most SBOMs, if they actually are based on real software, probably have 1,000+ components in them, right? And for a lot of folks, the top-level compliance of just the top-level license is not sufficient. I need to also know what all my transitive dependencies are and what all their license information is, and ideally where I can find the source code for them too. Most tools don't provide this information, right? If you just generate an SBOM, you may get it for certain ecosystems. I think specifically like Syft does a really good job for Java. But you probably want to go through and enrich these SBOMs with additional metadata. And a great way to do this is with Parlay. And what we have found is that it does a really good job adding a lot of that top-level metadata here. So here's, again, kind of an example of a single component. By using Parlay, it goes out to ecosystems, and we'll go out and find a lot of this, kind of like public metadata and enrich these SBOMs so it has a better description for each individual component, where you can find some of those external references and some of those additional traceability properties here. Again, as a consumer of an SBOM, I want to know all the information that I can get from that supplier of that SBOM to me. Having just a list of components forces me to go find all this information. It's much better if it's shipped with the actual SBOM document. All right, now that we've enriched it, we want to do some verification on it. right? I think, Gary, you're going to talk a lot more about verification, but there's a shocking number of SBOMs out there that don't actually comply with SPDX or CycloneDX spec, right? How do we verify it at a base format level is important, but then going up a level and say, okay, how do we also verify the contents of it a little bit more, right? Back to my story earlier. People release SBOMs with incredibly terrible data in them and say that they're compliant. Like, the number of people who release SBOMs that say like no assert on like license and say it's an NTIA minimum compliant document, large majority of folks do that, right? How do we actually verify these? So here's an example of using the SBOM QS quality score tool. And it creates a nice little table here that prints it out, but it gives a better idea of the actual quality of an SBOM, right? So in this case, after we've gone through this enriched process, it gives us a score of 8.3. It's kind of a meaningless score, right? But if you look through the individual steps here, it shows you the number of components with a name, the number of components with suppliers, right? These are the fields that we want as a consumer of an SBOM that give us a lot more information that helps us maybe go look up in our own systems for security scanning. Things like components with unique IDs is an important one, right? This allows us to have the information we need to actually verify that I want to consume the software. And if we look at kind of where we started, at the generation phase, where you just have a generated SBOM, and you go all the way through that augmentation and enrichment phase to the verification, you can kind of see it here in the bold. We went from having 0 components with a supplier to about, a little more than half of them. It added itself to as an author. We've dramatically increased the number of licenses that we had, and also, how many components actually have licenses associated with it, right? So we took some pretty standard open source tools, easy to add to your CI/CD pipeline, and we were able to dramatically kind of increase the amount of information that's there, right? And some of that stuff is stuff that you, as the supplier of that software, the author of that software, should be declaring. I wouldn't be remiss without talking a little bit about OpenSSF SBOM Everywhere standards. I think one of the things that we talk about, right, is it's great that you produce this SBOM. How do we put it someplace where it's easy to discover? Hint, it should be as an artifact as part of your release, or in a specific directory at the top level of your repo. And you should follow the naming conventions, right, that are laid out here. So knowing a release may have multiple artifacts, it should be whatever the artifact is that it's describing, the version, semantically released, and then CDX or SPDX, ideally in JSON, would be the preferred way of doing this. All right, so we verified it, has good content, we know it's format's compliant, and then I think we need to sign it, right? We put a lot of energy into this. How do I know that you are the authoritative source for this SBOM? Use cosign, right? Easy, again, to integrate into your pipeline as a way to sign this and be able to specify what the workload identity is that did this release, and that should ideally match your SBOM. So I'm going to just give a quick summary here, right? At the end of the day, a lot of folks are releasing SBOMs. I think that's a great first step. Next, how do we begin to make them, more complete, right? We can use tools to augment them. We can use tools to enrich them, and then to verify that we've done that and released a better quality SBOM through all of this. All of this is available as a working example out on GitHub. You can go to SBOM community/SBOM generation and see this for a variety of different open source ecosystems. So there's a Python one, there's one for Java, and one for JavaScript. With that, I'll turn it over, lessons learned, to Gary.
All right, so Ian talked about the process for building this. It's kind of interesting how I actually got involved with the CISA community. I was working on a Linux Foundation project. We were scanning a number of the Linux Foundation, and we came up with almost the same process that the CISA community did. So I joined that group, and through that group and through the work with the Linux Foundation, we learned a lot of lessons on producing quality SBOMs using the methodology Ian described. So on the road to building an SBOM, we ran into a few bumps in the road. So two sources of these lessons. One is from the CISA SBOM community itself. There's actually a white paper that describes it, but this is a collective experience from many practitioners of SBOM generation out in the real world. And all these, again, are captured in a white paper that I'll be summarizing here. Here's just a reference for where a lot of that information can be found. Same URL as that Ian mentioned a second ago. The second area is the Linux Foundation source SBOM generation work that I've been doing with Jeff. And we have a talk on Wednesday. I think it's now at 12:30 if you want to learn more about that particular. What? 11:55. Oh, you would have been there just at the end if you had listened to me. 11:55 on Wednesday. They changed the time on me. That's my excuse. And I'll go into exactly, a little bit more detail on how we're doing this. But in this talk, I'll talk about what we learned and what worked, what didn't work on the road to building these SBOMs. So these Linux Foundation, some of these are pretty huge projects, by the way, thousands and thousands of files, more than 2,000 repositories, 1.2 million files. So it's a fairly sizable scale of projects. So what are some of these bumps in the road? So Ian already mentioned the biggest one, and I have to say this just drives me nuts. How many times I get an SBOM that won't even pass basic syntax rules for SPDX or Cyclone DX. A lot of these actually, these fall into two main buckets. The biggest one is license expressions. People will pull, I shouldn't say people, the tools will pull the license information straight out of the metadata and just plop it in as an expression. It may or may not be a valid license expression. It may be like a sentence that says, this package is licensed under Apache 2.0. That is not a license expression that's parsable by any tools, but we find a lot of those. And then there's some incorrect usage of fields, some duplicate identifiers. The good news is whenever we reported these to the upstream tools providers, they've been very responsive. They've been thankful that we report them and pretty quick at turning them around. So a lot of these have actually been fixed. The other thing is the supplier data is missing. So at the top level, as Ian mentioned, these should be augmented by you. If you're supplying a package and you're not providing information about yourself as a supplier, that's pretty bad. That really needs to be there. But if you want to provide the supplier information about the lower level stuff, that we find a lot of issues where that information is just missing. And it's missing because it's missing in the metadata. So there are a few tools or a few techniques that we could use. There's some curated databases out there that have additional supplier information added that can be used to fill in these gaps. But that's one of the bumps that we've run into. This one's an important one for security, is missing version information. And what I would say on this is there's a difference between doing what we'd call a source level SBOM, which is where you take the source and you scan the package metadata, the POM files, the requirements.txt files, whatever they happen to be, and you try to construct from there. A lot of times those give very generic information about the version, whatever the latest version is when you build it. Well, who knows what was actually built into the package that's distributed. If you do a build time SBOM, you actually can know exactly what that version is. So the best solution is to use build SBOMs and be able to pull out. Some of these build environments, like NPM now has an SBOM command that when you actually run NPM, you can actually get the specific versions for the packages that were downloaded at that specific point in time. And so using these native tools and doing build SBOMs is two solutions to that. Another issue is the single points of failure. We do the Parlay uses ecosystems.ms. That is a publicly available utility. I think they're a nonprofit. They do a great service, but what happens if they're no longer funded or they move? I can't tell you how many package manager repositories I've had to switch over the years because the commercial company decided not to support that one anymore. So these things can go away, and that does provide a risk. So a way to mediate that is to use multiple different sources and multiple different tools to provide additional tools for augmentation. This one, This one's a little bit charged. I have a solution, which is just use SPDX, but no, I'm just joking. The data mapping between the standards is another issue because there are two dominant standards out there. There's a third standard that sometimes is used as well, but how do you map between them? Two things I would point out on this. Number one is I can say firsthand, we have worked between the two different standards to come up with a common set of mappings, and they are available through some CISA documentation and some spreadsheets that are out there, but they're from a subset of it. But they are the subset. That subset is a superset of the minimum requirements from NTIA. So they do include more, and they include most of what I've run into. So there is data mapping available, and there's a nice little tool called SBOM CTL that will allow you to translate between the two. So if your tool isn't providing the standard you want, check out SBOM CTL, download it, run it, convert it from one standard to the other. It does a pretty good job of doing the mappings. Ambiguous identifiers, I could actually spend the whole hour talking about identifiers because it's a very complicated topic, but they're critically important. The component identifier is really important for being able to associate it with vulnerability databases to know that if this BOM is talking about this component, it really is the same as this component over here. And a lot of the tools don't provide accurate identifiers, although I think it's getting better and better over time. This is definitely an area I see a lot of improvement. One thing I'd encourage you to keep in mind is there really is kind of two different types of identifiers out there. There is identifiers that talk about the actual component content plus the metadata. Things like package URLs, which tells you not only, what the thing is, but also where to get it, what language ecosystem it is. It carries a lot of the metadata information that's in there. And then you have content identifiers that will tell you that this is exactly the same bits between these two different things. And they really have kind of different use cases around those. So it's always good when you're producing an SBOM to capture both of those. Have something like a simple hash of a file is a good content identifier. More complicated, is it still called getoids or software heritage IDs? If you have a collection of files is another way of providing the content, but also have things like package URLs and CPEs to be able to capture some of the additional metadata. The other thing I suggest as far as having identifier types, there's kind of competing standards there too. There's no harm in including all of them. Anything you got CPEs, you got this, just put them all in the SBOM. And maybe one of them will correlate with the vulnerability database and you'll be able to get some good use out of it. There are some eco-specific challenges. C and C++ ecosystems have somewhat limited support for tracking dependencies. There's package managers that right on top of that do provide a lot of that information, such as Yocto, and I say that because Joshua is right there, and some of the other package management ecosystems. And then the other issue we run into is generating SBOMs where you have a mix of different language ecosystems. So you may have NPM that has a C++ embedded package. So how do you capture a complete SBOM around that? That actually can be a challenge. So despite all the bumps that I mentioned, really there's a lot of tools and support in place today that you can build some good, reasonable quality SBOMs. More and more package managers are integrating SBOM support directly into those, and that's my favorite approach to this because they know what's being built and can probably produce the highest quality SBOMs that are out there. Some tools are leveraging the existing metadata so that when you in the augmentation phase, you don't have to create a separate JSON file. It's actually in the metadata that you're already maintaining. So an example of that is the SPDX Maven plugin that pulls that information straight out of the Maven file and generates that. And useful source and source SBOMs can be generated today using the existing tools. And again, one of the areas that I've been working on is in the Linux Foundation projects. And come to our talk on Wednesday at 11:50 if you want to hear more about that. Before I turn it back over to Ian to close, I just wanted to mention one other bump in the road. I forgot to put a slide in on this, and that is at the performance. One thing when we were doing a lot of the augmentation tools in this, some of this can be rather time consuming because they go out to the internet and pull information down. Putting in place proxy servers to be able to cache that information we found to be quite important in the Linux Foundation. So one of the things we did, for example, we were pulling a lot of dependency information down from external package managers. We put in place a Syft Nexus repo as a proxy server, and it sped it up, I think, was it 3 orders of magnitude or 2 orders of magnitude? It made it a lot faster. I think we were running 12 hours for one of our projects, and it took it down to minutes. So it was a lot. So that's just another bump in the road. I just wanted to mention that we give you a little bit of practical advice from somebody who hit the bump, hopefully before you. So I'll turn it back over to Ian to talk a little bit about the next.
I didn't even know that was possible. That Nexus had a proxy for that. That's awesome.
Yeah.
Great.
Worked well.
Cool. So yeah, I mean, a lot of this work is happening in communities. We encourage you to swing by the OpenSSF booth. I see Alan in the crowd over here. We'll be kind of demoing this tool called BOMGTL that Gary mentioned tomorrow, so swing by and see it. We'll be there with Porco, who is one of the folks who created a protobomb, which is doing a lot of this type of format agnostic translation and management. So I recommend checking that out. And then if you don't know enough about BOMGTL already, you can also come see our presentation during the OpenSSF Community Day on Thursday. Again, we kind of highlighted some of these resources, but I think CISA is doing a really good job on a macro level, getting a big community together to work through SBOM issues. If this is something that you're trying to do, join that community. There's a lot of really good work happening there, and you can see it at cisa.gov/SBOM. A lot of the work that we did here, we tried to make it be really practical and hands-on. So there is also the GitHub repo out there at SBOM community/SBOM generation, where you can see working examples both in GitHub and GitLab pipelines for doing this. And then lastly, I think a lot of work has been done in OpenSSF to try to categorize tools and bring this kind of work to the forefront so you can easily see it. So check out the SBOM/catalog at OpenSSF that the SBOM Everywhere group has been working on, along with some of the technical initiatives that are out there too. With that, are there any questions?
Has this group come up with any best practices or guidelines on merging SBOMs from tools? Like you mentioned that NPM gives you the best analysis of the NPM install, but then you put it in a container with distro packages.
Yeah, so the question is, are there any guidance from the community on how to merge SBOMs? I would say the answer is no, from what I've seen. I've seen tools try to do it, and ultimately what we led to was almost not trying to merge them. And instead, what we've done is more of look at trees of SBOMs where you have maybe source SBOMs, and you have an ability to say okay, this SBOM, maybe it is merged, but has these other SBOMs as lineage, so you can see that extra information. Gary, I don't know if you've seen otherwise though.
No, I think I just mirrored the same answer you did. On the linkage, there is an advantage. I mean, I think both SBOM standards have the ability to link the different SBOMs together. The advantage of that, you can keep them a little bit more manageable. I mean, one thing we did on the Linux Foundation project, we did merge a source file analysis SBOM together with the dependency analysis, and we had to wrap it up in an archive file. We had to compress it into a zip file so that it would be able to be uploaded to Git. It was so big, it wouldn't, it just exceeded the 2 or 4 gigabyte, whatever the maximum was on that. So they can get rather huge. We have talked quite a bit about the linking, I think, in the community, and you could probably find a little bit of information on what we talked about there. But good question, though.
Yeah, thanks, Jeff. Any other questions?
Yeah.
Thank you, Jeff, for your talk. I'm curious, do you know all of the tools you mentioned, does that give you the information at the package level? It doesn't drill down to the file level, is that true?
So what's the question?
Yes. So the question was the tools that we mentioned they're at the package level. Do they drill down to the file level? First, that's a great question, and yes, it is at the package level only. There are tools that we didn't talk about here, but I know like in the Linux Foundation we use, in fact, I'll expand on that more than what we use Fossology to do the source file analysis, and then we merge the source files with the analysis with the package level analysis to give a complete SBOM view of the packages that are being distributed. Another tool that's really interesting in that regard is ORT, or OSS Review Toolkit, I think is what that stands for. And that'll actually download things from the repositories and actually include the source level information as well. So there are tools out there, but I think in most cases you're probably going to end up doing some kind of a SBOM merge or SBOM linking to get the complete picture. Yeah. Mm-hmm. Other questions? Yes.
Quick question. Do you agree with the statement that the best approach is to generate SBOM during the field that you have about the sources, how to build it, what you exactly use to build the content, and then just enrich it by additional metadata like you represent? Is it the best approach?
Yeah, I'll summarize the question because I don't think I remember all the important details you mentioned. Do we agree with the statement that the best SBOMs are built at or are produced at build time? I'll answer first. I'd say yes. And Ian, what do you think?
Yes, but I would throw out that there's not a lot of ecosystems that are doing that well today. So knowing that that's the case, any SBOM is better than no SBOM. But I think there is work within OpenSSF to try to figure out common ways of doing that. So there's a project called SBOMit that's looking at using strace or eBPF and to have a better analysis of source to compilation, independent of what compiler you use, and then generating total attestations around that. So it's a little more of a verifiable approach. So I think SBOMit is doing some interesting work in that vein. I think the downside of that, though, is you still need to do enrichment, you still need to do augmentation to add those top-level declarations. Mm-hmm. Great question, though.
Yeah, and I'll just add, there's nothing wrong with having more than one SBOM. So you can have a source SBOM, a build SBOM, and if you're in a deployment architecture where you're actually responsible for deployment, why not have a deployment SBOM that says not only what was built, but what's actually running, which may refer to multiple build SBOMs.
I'm pretty sure you just almost answered the question. One is, suppose that I'm building software and I'm sharing it through 3 package repositories plus a Docker container. Is it appropriate to share one SBOM per hosting or supplier, I guess?
Yes. So the question is, if I'm building one package but making it available through multiple different package manager or ecosystems for making those available, should that be one SBOM or multiple SBOMs? So I think I can answer for SPDX. The technical answer would be you really should do 3 different SBOMs. But you could structure them in a way that 99% of it's the same information. It's really just the augmented information at the top level, that would be different. And you could even split it into, one common SBOM and link between them too. That's possible. But you technically you should do three different SBOMs, and that actually is a really good opportunity for me to emphasize the difference between identities that are based on the content, because that's going to be the same in your example. You're going to have one content identifier for that, but 3 different identifiers for those packages, because they are downloaded from different locations, which in some cases can be very significant.
Yeah, just to add on to that, I think an example would be Go Releaser uses Syft under the hood to generate SBOMs. and it will actually do an SBOM per architecture and per platform. And so I think if you were following, again, kind of like what I put up here, this OpenSSF naming convention, you would then literally have like, 5 artifacts as part of that GitHub release and 5 SBOMs with that. And if you're releasing a container, which throwing an OCI compliant SBOM in there would be true. I think part of this though is kind of like the next evolution of this, and that's why we're kind of like talking a lot about BOM-CTL, is the idea that like, hey, what does a container image SBOM look like? Well, reality is it's probably one SBOM that says, here's my base container, and there's an SBOM for that, coming directly from, maybe it's Docker Hub with their authoritative SBOM, and there's a separate SBOM just for the build of that one executable. And you have a top-level SBOM that combines the two of them. So when Gary talks about linking, how do you link to those existing, I'll say like authoritative sources for that SBOM data so you're not recreating it again with Syft or Trivy, and probably not going to be as accurate.
Other questions?
All right.
Oh.
So, tiny questions. So, in your slides, the SBOM type mentioned that pre-build
What's that? Sorry?
pre-build SBOM type.
Pre-build? Or
So, is there somehow define some community or just you say? Because my question is, in NTIA document or CISA document, SBOM
Yes.
type is how to say, depending on the SBOM software development life cycle.
Yes.
Build, design, build, design, source, build, and so. But
Yep.
in your demonstration, pre-build. So what
Yeah.
that?
So in the document, at least for CycloneDX, I think they call it lifecycle. I think is probably what you're talking about. So maybe here where that build is coming from.
oh, yeah.
So it kind of goes back to the different types. So are you building it from source? So you literally just have source code that you're generating an SBOM from? Do you do it as part of a build compilation so you know what the binary is that's produced? Or are you doing it through analysis where you have a binary, but you don't know what the source code is? And so you're trying to reverse engineer what the SBOM contents are.
So that the term is defined only in the context of CycloneDX.
I think
Yeah, I
SPDX
think
probably,
that,
in
yes.
this case,
Yeah.
this one, yes. But
Yeah.
SPDX probably has to say.
Yeah, SPDX follows the CISA naming convention, so we would say source. We'd have an SBOM type of source, which would map directly to the CycloneDX terminology. Yeah, so it's just a difference in the naming. And to cut a little break for CycloneDX, I think they came up with those before the CISA terminology. But they do map. Yeah. Yeah, good question. Any
All
other
right.
questions? All right,
Well, thank you, everyone.
thank you.